Hi guys, this video is brought to you by Group 3 and it is about the overview of our food waste treatment plant. In Malaysia, 15,000 tons of food waste is produced daily, with 80% of it entering the landfills. Landfilling has three main negative impacts on the environment, with the first being leachate production. If not tackled properly, leachates can cause soil pollution and water contamination. The second effect is odor production, which can cause irritation to human respiratory systems. The emission of greenhouse gases from landfills contributes to global warming as well. Therefore, with environmental protection and sustainable development as our priorities, a greener food waste treatment technology that incorporates both anaerobic digestion and composting techniques is utilized in our proposed plant. In this plant, we focus on converting 3,000 tons of food waste per day into two main end products, namely fertilizers and biogas. Now we will show you the equipment inside the main building of our integrated anaerobic digestion and composting plant where most of the processes take place. The layout is designed to keep the convenience, efficiency, safety and environmental regulations required by the government of Malaysia. This grey Lego is the control room which operates the whole processes and systems. These dark brown Legos are the unloading and loading bay. The orange Legos are the packaging and storage units. There are two rows of processes in our plant, the anaerobic digestion roads and the composting roads. This is the anaerobic digestion road, while this is the composting road. These two black tanks are the anaerobic digesters. The biogas that produced will follow this path to the desulfurization units and the gas chambers. Conversely, the digestates will undergo dewatering in this purple unit and join the composting road to produce organic fertilizers. We will now move on to the overview of the major processes within the plant.
The first step in our food waste treatment plant is the collection of food waste from restaurants, schools, hospitals and other food and beverage manufacturing plants. Next, the food waste collected will undergo a sorting process, separating magnetic and plastic waste. Then, the organic fraction of the waste will be sent for crushing to generate a fine and consistent sludge product. This sludge will later be pasteurized in a tank at 70 degrees Celsius for 1 hour to destroy the pathogenic organisms. After that, the clean slurry will be piped to the digester to undergo the anaerobic digestion process. The two main end products of the anaerobic digestion process are digestate and biogas. The digestate discharge will be further treated through dewatering and composting to produce organic fertilizers which can be sold to farmers to generate profit. On the other hand, the biogas produced will be desulfurized and transported to cogeneration plants for power and heat generation purposes. Now, let's have a look at the Lego model of the magnetic screening belt in our plant. This magnetic screening belt model is created using Studio Bricklink and programmed using VRT. This belt is used to separate magnetic waste items such as metals from the rest of the waste. The magnetic screening belt we designed consists of two conveyor belts. This is the bottom conveyor belt while this is the top conveyor belt. The bottom conveyor belt transports the food waste, whereas the top belt is equipped with magnets and will attract the magnetic waste. The two belts will turn at different directions, one in the clockwise direction and the other in the anti-clockwise direction. To ensure that the whole structure is stable, a large base area is designed. This magnetic screening belt is also equipped with an EV3 intelligent brake which is programmed to run an EV3 large motor and two EV3 medium motors in order to turn the conveyor belts. This clip shows a simple representation of how the belt works. Next, we will show you a clearer view of the operation of the belt by programming it in VRT. Now, you have reached the end of our video presentation. Do leave us a thumbs up if you find this interesting and informative. Thank you for watching.